The question we are solving now belongs to test series 3. It is of control system subject. In specific, it belongs to root locus of the control systems. As per the question, the open loop transfer function of a unity negative feedback control system is given as k divided by s into s plus 3 multiplied by s square plus 2s plus 5, where k is greater than 0. There are three statements given as related to the root locus of the control system. The statement one says that the value of k for which the root locus intersects with imaginary axis is 24, and the statement B2 says that root locus doesn't lie at the point minus 2.5 on real axis. The statement 3 says that root locus starts from 0, minus 1 plus or minus 2j and ends at minus 3. It also says that the number of root locus branches is 4. We need to pick the correct statement, or we need to pick the set of correct statements out of these three. So from the given open loop transfer function, we see that the characteristic equation of the control system can be written as 1 plus g of s into h of s is equal to 0. This can be further simplified as s into s plus 3 into s square plus 2s plus 5 plus k is equal to 0. So from this, the characteristic equation of the control system can be written as s power 4 plus 5s cube plus 11s square plus 15s plus k is equal to 0. The value of k for which the root locus intersects with the imaginary axis can be obtained by Routh-Hurwitz analysis, for which the Routh array is formed as shown. The Routh array's elements in the first two rows are written as 1, 5, 11, 15, k. So the entry at this point can be written as 5 multiplied by 11 minus 15 divided by 5, which upon simplification can be written as 8, and the entry at this point can be written as 5 multiplied by k divided by 5, which can be written as k. And the entry at this point can be written as 8 multiplied by 15 minus 5 multiplied by k divided by 8. So which upon simplification can be written as 120 minus 5k divided by 8. And the entry at this point is k. We know that for marginal stability, for stability, the entries in the first row should be greater than 0. So for marginal stability, k is equal to 0, or 120 minus 5k should be e should be equal to 0. But it is given that k is greater than 0, so k equal to 0 is not a valid point. So from this we see that for marginal stability, k is equal to 24. Hence the correct statement is, so the statement 1 is correct. And also we know that the root locus lies on the real axis at a point P if the number of poles, or either if the number of open loop poles and zeros to the right of that point P is odd. So now we have to find if the root locus lies at minus 2.5, and from the given data we can see that the number of poles and zeros to the right of minus 2.5 is 1 plus 2. That is, this one corresponds to the pole at 0, and this 2 corresponds to the poles minus 1 plus or minus 2j, which correspond to the term s square plus 2s plus 5. So this is equal to 3. So as this number is odd, the number of poles to the right of the section minus 2 to the right of the point minus 2.5 is odd. Hence the root locus lies at the point minus 2.5, and so the statement 2 is not correct because it says that root locus doesn't lie at the point minus 2.5. And also we know that the root locus starts from open loop poles and ends at the open loop zeros or infinity. From this we can say that root locus starts at 0, minus 3, and -1 plus or minus 2j, and ends at infinity as there are no open loop zeros. And also we know that the number of root locus branches is equal to maximum of number of open loop poles comma number of open loop zeros, which upon simplification becomes 4. So from this we can say that the root locus starts from these 4 points and ends at infinity, and the number of root locus branches is 4. So the statement 3 is also not correct. Hence the statement 1 is the only correct statement. Hence the correct option representing the correctness of the statements is B.